Welcome back. This is the second of the two optional programming activities linked to the binary search tree topic. In the last of these lessons, you made a binary search tree using a 2D array. In this lesson, you'll make it using object-oriented programming. As always, pause at any time and try to do the work yourself, but I will take you through the whole thing step by step. In this lesson, we'll do the OOP commands to create a single node, create the node class, that is, to create the tree class, and to make a method that lets us add a node to a tree. At the end, I want to briefly compare this type of programming with using a 2D array. So what we're going to do first is write a program that makes a node class, makes a tree class, and which is a tree is a collection of nodes, and then we're going to declare a single instance of the tree class. Have a go. So the first thing we're going to do is to create a node. Nodes of a binary search tree have got 3 attributes, some data and 2 pointers. Of course, if it's a different kind of tree, the nodes will be different, but this is what we've got. So some data and 2 pointers. So make that using OOP. Pretty obvious. The class I've called node, and the constructor has 3 attributes, data left and right, and the data is sent as a parameter from the calling program. And now make a tree. Remember that when we begin a tree, it has a root node and nothing else. The value of the root node is sent from the calling program. So let's make that. The tree class is even simpler than the node class. It's got 1 attribute, which is the root, and that's all it's got when you create it. We don't need a list or anything. And then in the main program, I get some, I can see I've put an error in my code there, which is value shouldn't have a colon after it. I have some error. Value is an input value, and then we create a tree with value as the root value. I'm not going to redo this. Ignore that colon after the word value. All right, now we've only got to create one method. It's a tree method. It belongs inside the tree class, and it's going to be called append, and it will let us append a data value to our tree as a new node. What I suggest you do is copy the append procedure from the 2D array program and change it so that instead of using elements of the array, we use attributes of a class. You don't need a free pointer. So if you fancy a challenge, have a go at it. Otherwise, I'll take you through it step by step now. So we're going to create a method in the tree class. It's the only method we're going to create for now, and it's going to be called append, and it's very, very similar to the append function that you just wrote using the 2D array. But notice that when we're using object-oriented programming, the code is a little clearer, I think. So we're going to, before we started at my tree square bracket 0, that was the starting node, but in the new program it'll be self.root, the root of the tree. And where in the other program we talked about node 0, node 1 and node 2, we're going to call it node data, node left and node right. So the 3 attributes of the current node. Let's write that. So we start at the root, and I've put the whole thing inside a while true loop as we did before. If the value is bigger than the data, move to the right, otherwise move to the left. or you could do it the other way around, but whichever way round, it's the left-right rule. So if the value is bigger than the data, move to the right, otherwise move to the left, and that becomes the new node. So we're going from node to node through the tree, jumping to left or right. You can remember when we were here in our previous program, I said, great, this will jump us through a tree forever. And there has to come a time when we stop jumping left and right and stop and add the new value. I'm sure you can remember when that is. Let's look at what that would look like in practice. Let's say that the value is larger. So we would jump to the right. When would we stop? If that right pointer is empty, we can't jump to the right. Instead, we create a new node at that position and return to the main program. So that would look like this. So if the value is bigger than the data at the node, and if the pointer is none, then make a new node with the value and point to it. Node right would become the new node and return to the main program. Otherwise, jump to the right. Then you can see else. See if you can fill in the remainder of this append method by simply a mirror, more or less a mirror image of what goes before it. Let's have a look. If the node to the left is none, create a new node and return to the main program. Otherwise, jump to the left. That's it. Can you see I think it's a little bit simpler and easier to understand this code than when we were using the 2D array. We don't have to worry about the free pointer, and because we're using attributes, I think the code's a little bit easier to understand. And the main program is almost identical to the previous program that we wrote. The user inputs a value and appends to the tree. There is no free pointer, so the code's a little bit less fiddly. And what stops this loop? There is no upper limit in terms of size because we're not using a fixed array. But if the user wants to stop, if they just press enter instead of a value, then that will break the loop. So just step out of programming for a second. Just think about those two experiences. I hope you've created this now in two ways, once using a 2D array and once using object-oriented. Object-oriented is better in some ways, two very important ways. The programming is a little bit easier, I believe. And also there is no upper limit to the size of the tree. So we're not creating a fixed array, we're just creating new objects in RAM, and the computer is just accumulating those nodes, so the tree can be literally as big as we like. However, there's clearly one big disadvantage. We haven't created a show procedure. You can't just ask the computer to print out the tree. You can try it if you like, and you'll see it won't work. That's a big limitation of object-oriented programming, that unless we specifically tell the computer how to print out the object, it won't know how to do it. And that is a whole new program which we're going to do next week, actually, the next working week. So I'm kind of going to leave you hanging there without being able to print out your tree. So with that in mind, can you make a program using object-oriented programming just in the way that I've just shown you? And if you want a bit of an extra stretch, you could embed it in some sort of random number generator, so it creates a random tree of any size that you like. But be patient, because next time I'm going to show you how to add a traverse procedure which will visit every node in your tree and print them out one after the other. All right, So with that in mind, bye for now.